everyone. Welcome to Demystify AI, the fundamentals and implications. My name is Xiaopeng. I'm part of the organizing team, and I'm also the board member on Oslo.AI. With me today, we have Thibaud from Pint of Science.
Hi, everybody. So yeah, my name is Thibaud, and thanks Xiaopeng. I'm the founder and director of the Pint of Science Norway, and Oslo, a member of the Oslo.AI organization as a volunteer.
Fantastic. So let's start by giving a bit brief introduction on the two organizations behind this event, and then we will talk about the agenda and the speakers today.
So yeah, thanks Xiaopeng. So the Pint of Science is a concept that is born in UK in 2013. And it has been growing since. So for instance, it now is present in 29 countries. And the concept is to bring scientists and researchers in cafe on board to engage with you to explain their science. And what the particularity of this festival is, it is international. So next, please. So for instance, Xiaopeng, can you?
Yeah.
Yes,
Sorry.
thanks. It's fine. So in 2019, so we were the festival represents 23 countries, and every Barnet, which is the mascot of the Pint of Science network, is actually one town where it was events. So we can see that the most activity is in the whole continent and Brazil. But now we are present in 29 countries. So Norway, next please, joined the network in 2020. And so we have 30 volunteers now, from a PhD student to associate professor and professor. Maybe we'll manage to have some emeritus professor if we can. And we are present in 6 cities. And this kind of event with Oslo.AI is what we call a special event, because our main activity is a Pint of Science festival that I explained the principle on, that is all at the same time in every country. So in Norway, it will be from the 19th to the 21. And if you want to know more or subscribe to our newsletter, you can find us at the pintofscience.no. And we try as well to be present in every major social media to be closer to you. So please just follow us and enjoy this event.
Thank you, Thibaud. And it's really impressive that you guys even have a chapter in Longyearbyen. Really reaching out. Okay, so let me move on to a brief intro of Oslo.AI. So I think many of the folks in the audience have probably heard about Oslo.AI or have joined our previous events already. So Oslo.AI similarly is a global network. So the network is called City AI, and we are the local chapter here in Oslo. So as you can see from this picture, we have chapters really around the world, all the way from Africa, Asia, Europe, US, etc. So the local chapter here in Oslo are represented by the 6 board members on the slide, as you can see here. So we have Lillian and Irvin from Meta, Alise, who is doing a PhD in UIO, Abby and myself from Microsoft, and Håkan from Miles. And you see, I put the confetti emoji on the 3 female board members, not because they're having birthday on the same day, but because they are all featured in a recent article and list from Nora on the female role models, which are really making impact in the AI landscape within Norway. So congratulations to all of them again. So the agenda for today, we will have 3 parts. We will start with an opening talk with my colleague from Oslo.AI, Alise, who will give you an introduction on the fundamentals of AI. So what is AI, what is machine learning, and what AI can do now, and what are the capabilities of AI today. And then we will move on to a moderated panel discussion, moderated by Inga. We will end with a Q&A. So I just want to remind you that you can always ask your questions during the session, and we will try to address them while we go. And also, please be very active when it comes to the open Q&A by the end. We want to engage and interact with you guys as much as we can. So before we start a talk with Alise, I also want to quickly mention the moderator and the panelist of today. So they will introduce themselves, briefly later, but I just want to mention the names quickly here. So we have Inga, who will be moderating the panel, and then I have myself, Alise, joining as the panelist. And I mentioned both of us before. We are part of the Oslo.AI board, and then we have Alex working from NORA point of view on AI ethics and policy. We have Majid, who is also doing a PhD in deep learning in UIO, while working as a deep learning engineer as well. And then we have Michael Alexander, who is a research scientist from Simula. So you will hear more about their background and their perspectives very soon. But before that, let's hand over to Alise for the opening talk.
Enjoy.
Alise, you're on mute.
Sorry, I was muted. Thank you for saying. Hi guys, here I am. And thank you so much for joining us today on our journey to demystify artificial intelligence. My name is Alise Midtfjord, and I am a PhD student at the University of Oslo, where I do research on machine learning. And I am here right now to give you a brief introduction to the fundamentals of artificial intelligence, so that you can catch up with the discussions later and maybe get your own questions and get your own point of view on our topics. So I want to start off by giving you some facts to get you up to speed on how the world of AI is doing right now. So in 2019, AI adoption among large companies has increased by 47% compared to 2018. And AI computing power keeps doubling every 3.4 months, actually. And in 2019, the global private AI investment exceeded $70 billion. And for the future, by 2035, the annual economic growth rate can actually double. So every year it doubles. So we see there's a lot of reasons why everyone should learn what AI can do and what it actually is. So please follow up on the next slides. So I have here a definition that I've written for you about artificial intelligence. And I can just read it for you, that AI is a wide-ranging branch of computer science, which is concerned with building smart machines or systems capable of performing tasks that typically require human or other kind of intelligence. So some examples that you might see every day that kind of use AI and do these kind of tasks is a task of recognizing faces. It could be a task of finding out the best route for you to drive your car when you go to, for example, see your grandma. And it could be Facebook trying to figure out what you like and giving you kind of the information you want. Or it can be this kind of, at least I think, really annoying chatbots that you meet online when you're trying to give them questions and they never only answer questions. But there are three terms in this world of AI that are used quite interchangeably, and I want you to be able to distinguish between the three terms. One of them being, of course, artificial intelligence, which I just told you is mimicking the intelligence or behavior of humans or other living entity. The other one is machine learning, and machine learning is basically just a part of artificial intelligence. And it is the part of artificial intelligence that uses techniques where machines learn from data. So machine learning are basically systems that you do not hard code to do specific tasks. You just kind of teach them to learn, and then they learn how to do the tasks by learning from experience and data. And then we have deep learning, which is again just a part of machine learning, and it is a technique to perform machine learning that's inspired by the brain's network of neurons, and it's also sometimes called neural networks. So, for example, chatbots, it can be AI, but maybe not be machine learning. It may be just hard-coded to answer your questions, or at least try, but maybe it doesn't learn anything from the conversations. And for example, when you're driving a car, these routes can be optimized by using all the kind of machine learning techniques than deep learning. But very often, like face recognition and video recognition uses deep learning to kind of do their tasks. So now you know how AI works. Then another question is, what is AI capable of doing today? And I want to go to a few examples of things that I think that fields that really have adapted AI and use it quite a lot. And I would say that this recognition system, like this, where you get information and you get recommendations and personalized experience, that's a field where it uses AI a lot. For example, Netflix, Spotify, these Facebook feeds, LinkedIn feeds, or even Google searches or online shopping. They try to learn your behavior and then give you some recommendations based on what you like. I already mentioned this face recognition, but they can be used for better things than just giving you bunny ears on your Snapchat filters. They can also be useful for security. And we see that the security industry has really taken on AI. They can use it for example, antivirus to detect threats. And they can also use it for example, spam filters have been using and learning for quite a long time. And another field that uses AI a lot, maybe that we as end users don't see as much, is, for example, in industry where they use forecasting, prediction, and optimization quite a lot. For example, the financial industry can predict the stock markets, or maybe every store can predict its own sales. You can kind of predict maintenance, or you have to fix anything on your industry. And maybe you can kind of optimize your warehouses or optimize driving routes. So we see that a lot of companies use AI kind of in the background, even though you don't see it in your everyday. And a last example, also, of course, the car and automotive industry. If you ever sit down in a Tesla car, you might know what I mean. We kind of see how it kind of sits on the road in its way and know how to park on its own, and we see that we might soon get autonomous cars. So now we have seen some of the things that AI can do. Another question is then, what can't AI do? What are the limitations of artificial intelligence today? And I guess some of you have seen this movie, at least heard about it. It's quite old now. It's called just AI, and we see here a kid and they're both robots, but they behave and act just like humans. And the short answer kind of to what AI can't do is that we are not here. AI is not here. This is science fiction. This is movies. And some kind of easy explanation to that is that AI, it's artificial intelligence, is kind of not intelligence. It's just mathematics. It's kind of optimization. And they're very good at optimizing and doing just one task. They're good at kind of, you do that, and they do it might even better than humans do, but just one task. So it's kind of an ecosystem of AI systems working together. And there are a lot of reasons why we are not there. And I guess one of the main thing is data, because as a lot of people know, data is what fuels machine learning, because we have to learn how to work and make the systems. And kind of a lot of the big companies like Facebook and Google, afterwards Microsoft, they have a lot of data and can create good AI systems. But a lot of them normal companies don't have good and structured and good quality and not enough amount of data, meaning it's not so easy to create these systems. And I guess we're going to come more into limitations and some reasons why during our discussions later. But I'm going to end up with telling about some of the social impact and implications of artificial intelligence, because we are using it more and more, and we do see that it impacts our society in some ways. And I guess like the biggest discussion is about ethics, because artificial intelligence, it does arises some ethical questions. And one of the big one is regarding data, because I kind of say like artificial intelligence they're kind of like children. They do not do what we say that they would. They do not do what we say they should do. They do what we do. Meaning that if our society has bias or we kind of do something discriminating, the AI system learns from us and it also becomes biased. So it's easy to kind of see how this can arise challenges. Another topic is, when I talk to a lot of people, maybe many people that doesn't know what AI actually can do, they're quite afraid that AI can take over jobs. So I read this article saying that they think in the UK, AI can take actually over 7 million jobs by 2037. But they also say that AI could create more than 7 million jobs, meaning that we will take jobs. AI can create a lot of new jobs. So we'll just see a shift in what kind of tasks we have to do, what kind of skills are needed. And in the end, I also just want to mention that AI is just a technology. So we can see that this technology can do a lot of good. It can increase our economics. It can help us in medicine, a lot of other areas. But of course, it can be used for not good tasks as well if we program it to do so. So an example of this is, of course, the score system in China, where everyone gets scored depending on how they behave, and they get monitored with cameras, etc. And we see that the system is highly empowered by AI. So of course, AI can also be used for other kind of tasks. But again, it's just a technology. That's why it's so important to kind of see what challenges come to using technology, what we have to do to solve these challenges, and how we have to work as a community together to find out how we want to use AI. So that was just a really quick and brief introduction to the fundamentals of AI. I hope you will have this in the back of your head when we're going towards the discussions in a moment.
Yeah, thanks, Alise, for these clarifications. Before we move deeper into the subject, if you have any burning question, please shoot them in the chat so we have the chance, Alise, to answer it. And if there is nothing, we're going to move on. So we can wait 10 seconds. I believe that nobody has question. So thanks again, Alise. And now we move to the panel discussion, which will be moderated by Inga. So please, Inga, the stage is yours.
All right. Thank you so much, Thibaud. And thanks, of course, Alise, for the introduction. Now, I do look forward to having a discussion about this incredibly promising technology that we're surrounded by. So we will get right to it. But first, I'd just like to repeat what Xiaopeng said. Please, dear audience, do ask any questions that you have for the panel along the way, and we will try to answer them all right, because your questions are the most important ones, not mine. Okay, so let's get to it. Okay, so we kind of understand that data is incredibly valuable, and we've heard in Norway that it might be the new oil and so forth, but we still need to get the data, the value out of the data first, right? So I would like to address the first question to Michael. Michael, how do we get the value out of the data, and how do we make sure that the results are reproducible when there is, so much different data roaming around out there?
Thanks a lot for the question. So I don't think that data should be seen as the new oil, because I think it's much more than that. And also data, as I see it, is something like a common good. So I think it's really important that we have open data and that we have data sharing, and yeah, in my dream world, all the data would be open. Of course, a lot of privacy people now would like to kill me, but I kind of think about the optimal world where everyone would love everyone and these things. But why I want to have data open and why this is important is because the systems that we built, the AI system, they are only as good as the data we use to build them, and also the data we use to evaluate them. And for good evaluation, you need good data, and that's really important. So if, for example, your data is biased from beforehand because you didn't collect a good representation of the world, you train your model, you evaluate in the same distribution, you will get a model that shows, oh, wow, look, I can do 99% whatever classification or whatever task you want to solve. But it actually doesn't mean that you do that, that you solve the problem in the real world. That means you solve the problem in your small bubble kind of world. And also, if you don't share your data and you don't make it open, it also hinders open and reproducible science, which is really important, especially in the field of AI, because the AI field is growing so fast and kind of exploding. And there are so many studies coming out there that it's really important that we kind of check on each other, not because we kind of want to maybe do bad things, but also we are just humans. We can make mistakes, and it's important that a lot of people get the chance to check if we do things right, and also can improve on our results and so on. So I think that's really important.
Yeah, I think that's a good answer, and I think this is a good occasion also to bring Alex into the panel. Alex, I think you're the one in Norway that I know who knows most about AI policies. Now we understand kind of that AI can solve difficult problems sometimes better than humans even. But based on what Michael says, how do you think that AI will affect society kind of in the long term, and how do we make sure that it doesn't create more problems than it solves?
Yeah, I think that's a great question. I think Alise touched upon it as well, and I think I do not like to predict the future, but I think sort of like when there are some kind of larger discussions that kind of say that whether AI can be kind of better than humans or like best us in a way, and I think it is a trick question, and why? Because AI is shaped by humans, embedded in human processes. So AI is an extension of human frameworks for decision making to some extent. However, I do think that the work that Michael does is incredibly important because it does. I believe it will save a lot of lives, and I think that this domain expertise, is so necessary. Yet that possibility in diagnostics and getting better results together is fantastic. So we need to build the competencies in the general population to understand artificial intelligence, and we need to continue discussing how to be better humans. So secondly, because this is the first thing, and the second one is that long term, I have this wish list, that we move towards planet-centered AI as well, because we have some issues right now that we need to address, because there are likely to be new pandemics in the future. AlphaFold from DeepMind, with more open source, that's the kind of more protein structures. But Michael says an important thing as well, like maybe we need more like open source work as well into predicting these kind of structures. That can be important for understanding life, and ourselves, but also how we can address that issue. And then there's a second big curve, ahead, which we are all unfortunately trying to discuss how to solve, the climate crisis. So my wish on that wish list is that we ensure both the overall responsibility of the technology industry and that we develop applications within the field of AI to assist in this effort to reduce CO2, and ensure that our planet does not get overheated, so that we are stuck in this, horrible situation together. So those two things are on my wish list, and I think kind of we are wanting to work towards that through research and through collaboration.
So you bring up a lot of interesting points there, and I would love to bring in Xiaopeng right now. You work at Microsoft, and I think an interesting thing that's going on in AI is that we see huge private companies actually investing in fundamental research for, I don't know if it's kind of the first time, but the first time at this scale. And of course, that's not paid by our tax money, it's paid by the companies themselves. So could you kind of comment a bit on whether those results, which could improve the kind of life on Earth, should be open source, and also relate that to this thing called the reproducibility crisis in AI?
Yeah, so well, you really put me on the spot. That's a very, very good question, but very difficult one as well. So I would say, obviously there are technologies and techniques in AI which will be open sourced by default. Like, in the era of big data processing, we have things like Hadoop, which are open sourced and they are used, across the world. But then you also have the more sort of the private version of those. I think the same thing would happen, in the AI world. And obviously there will always be, intellectual property, developed by private companies. But I think, for the big techs, they have more responsibility to empower, other companies to develop AI solutions. I'm saying that because, if you look at the focus area of, players like Microsoft, AWS, Amazon Web Services, or GCP, Google Cloud Platform, what they focus on are not really the solutions. They're building the infrastructure. They're building the platforms so that other companies can build solutions on top of that. So I think, that would be the angle that the big tech should take to show their responsibility and to show their empowerment to other companies.
Oh, that's a very nice answer. I can tell that you have talked in front of a camera before. So I want to bring in the last two of our panel members, because now I see that questions are coming in and nothing makes me more happy than that. So if we can just bring in the other two, then I would just kind of like to ask Alise and Majid both the same question, kind of based on all these difficulties and challenges. How would you say can we make sure that AI systems are trustworthy, and what are kind of the main challenges there? So I'd like to do Alise first and then Majid.
Yes, that's also a very important question. So said about this trustworthiness. And I work a lot in my PhD with creating what's called explainable artificial intelligence. And that is kind of, if someone knows about the black box system, that there are some algorithms that we don't know how it works, then I try to work on how we can open them up to try to get some understanding of what's actually going on. And I believe that we don't necessarily need to know exactly everything about how a system works. I kind of think it's in the definition of explanation, because explanation is kind of simplifying how something is done and kind of providing this information to someone. So I believe that when you're trying to create a system that we can understand, you just needed to give it some form of explanation why it does what it do. So if it has made a decision that's important, we humans need to understand the system a little bit. Why does it? We do not understand need like every node of the system or anything. So I think it's really important that we work on creating explainable artificial intelligence, which is basically just a kind of easifying of the system so that we can understand it.
Yeah, and building on Elisa's answer and taking a little bit from Michael, for building explainable or transparent AI, I think we should start with a data governance strategy. And that is what data was collected to train this model, how that data was tested on that model, and what was the output. And there are several strategies that already exist there and several standards that outlines how you should collect data and how do you prevent the imbalances in data and the biases in the data. So I think if we have all the data available that's been trained by the model, which set has been used for training, which set has been used for validation, and which set has been used for testing, sort of that black box isn't really black box anymore, because we do know the data that has been provided to it, and with what constraints. So I think I'll leave it on there for now.
All right, thank you. Xiaopeng, do you want to chime in?
Yeah, I do. So I do have 2 points I want to mention here. One thing is that, when people think about, the amount of data we're using for, the training of AI or machine learning models, people get scared. But, we have to, distinguish between what is personal data, what is sensitive, what is regarding privacy, and what not, right? So there are a massive amount of data, for example, weather forecast data, which can be used without much concern, right? It's not linked to any individual. So I mean, we should, begin with the distinction of what data is sensible, should be handled with care, and what data can be used more at scale. And the second thing I want to mention is that, with the R&D into the AI space, now we also have the concept of, confidential computing. It's a relatively new concept, but that means, you can actually tap into the information within data and train models using the data without disclosing, any sensitive information from the data. So that's something still in development, but with that rolling out, I think we can, have even more opportunity tapping into the power of the data without sacrificing from a privacy or sensitivity point of view.
All right, thank you. Now, I guess we should open up for questions from the audience. So I guess we should get it up on the screen now. What about empathy next to ethics? I don't know if I can interpret that question, but Alex, my bet is that you can.
It's open for interpretation. Do we understand empathy properly? Do we understand how humans empathize with each other? I think it's sort of not two separate things. I think we have to kind of think a lot about empathy, but also kind of in that question, I think it's important to think about, of course, bias is really important and testing models and so on, but we have to also test, it's kind of hard, but we have to test outcomes, and that becomes really, really difficult in a lot of situations because algorithms can have very adverse outcomes. So we have to think about, empathize as humans and think about the outcomes of different algorithms and the values that we have in society to empathize and think, what is a good human being, right? And that's a very difficult question. But that's something that is integrated into the discussion of artificial intelligence. I don't know, that's just a short answer, but I think that's really important.
Yeah, and I guess it also goes to show that when you're building AI solutions that will affect humans in some way, you need to include maybe an ethicist, maybe somebody from the humanities, because we data peeps can't all be ethics experts. I think we have another question. Yes, Musk has repeatedly warned that AI will soon become just as smart as humans, and said that when it does, we should all be scared because humanity's very existence is at stake. Michael, this question has your name written all over it, doesn't it?
So he's a salesman. I guess he wanted to push some stocks or something like that. So I don't think there's any truth in that in this comment from him. So I would just say it's bullshit.
Can I just? Yeah, I saw Alex raise his hand first.
Oh, you go first. You go first.
All right. So I was thinking that actually right now there are certain technologies which push the AI towards very close to human parity. If you think about, when we do computer vision, or when we do, voice recognition, companies like Microsoft, Google, etc., have really pushed the limit, and now actually those technologies are very close to the human capability in that particular space. But bear in mind that AI and machine learning technologies are still very specialized. That means you have an AI solution which can recognize voice. That's it. An AI solution which can can read text or can understand invoice. That's it. But even AlphaGo cannot do a laundry, right? So machine learning and AI solutions are very specialized right now. So I would say, from a narrow intelligence point of view, in some areas, they're close to human parity. But in general, when it comes to artificial general intelligence, it's far from that.
So before giving Alex, who is desperately leafing through his AI policy documents, I'm joking. Before sending the question to you, I would like to just remark that in the United States, there are some states where humans can actually be fired by AI systems. So personally, I think that what we should be afraid of is not their intelligence, but what we let them do with perhaps lack of intelligence. But Alex, give me your hot take.
Yeah, I think, sorry, a hot take, but this is actually really a book by Stuart Russell called Human Compatible, which is really kind of like discussing those type of issues, but kind of breaking down all the arguments about this existential risk discussion that Elon Musk is part of, but there's a lot of other people within the scientific field that are contributing to that discussion, like but Max Tegmark is one of them, but there's a lot of different arguments, and he breaks down a lot of those different arguments and kind of discusses them quite in depth. But one sentence that kind of sticks with me in this is, machines are beneficial to the extent that their actions can be expected to achieve our objectives. But then he also says, but do we know what those are? Like, what are our objectives, to some extent. So I think, long term, if that is, thinking about this risk of super intelligence of like Nick Bostrom and so on and so forth, I think, yes, we have to have that discussion, but we have to think about now as well. We have to think about like this narrow applications and how they're applied. And, we cannot act out of fear. We must act out of compassion. So that's just kind of my quick rant on that topic.
All right, thank you. So we do have a question with us from before we started the session, which is, why do half of all the AI projects fail, and what do you guys think? So I want to send that to Majid first.
Yeah, I hate to say it, but it's not half, it's 85% of the projects fail in AI. And there are many reasons around that. So if we were to establish that you have the data in place and that you have the resources in place, what differentiates a successful project from an unsuccessful project? And the first thing is that many of the models do not graduate from the data science team into production. So you'd have a specialized team of statisticians working with some developers trying to put this model together. But what they do not take into consideration many times is, what does the equipment look like in the field? So if you develop something that's computer intensive, then perhaps you would need the required computing power deployed in the field. For example, in a in clinical environments where you want to introduce some machine learning, you cannot all of a sudden go around all the computers in the hospital and start plugging in powerful GPUs into it or improve the CPUs. The second thing you should take into consideration is that the tight coupling of software. So many projects already exist out there, and the companies that can actually afford to take the models into production, they usually have existing projects running. So the question becomes is, how do you integrate machine learning into your existing complex project? And usually you have a lot of dependency issues and a lot of other things that one didn't take into consideration. And after you leap through your software and hardware limitations, you have standards. There are many existing standards that you should take into consideration if you want to develop machine learning algorithms for industry, like as mentioned earlier, the clinical environment, or in aviation, or in anything really. So these silo teams not working together, taking into consideration these factors, is one of the main reasons why AI can fail. It's the technical feasibility of projects. And this mistake seems so common that the number is really high. I think you can find it on Pactera and Gartner on why many projects has not yet graduated from research into production. There are other reasons, but mainly I would like to keep it into that.
All right, thanks a lot. I can see that Alise is kind of just itching to get in here, and I think that the next question is very relevant in that vein. So, Alise, what would you say? What's the biggest challenge in implementing an AI project? 3 exclamation marks.
Yes, earlier I worked with consultancy. I worked with trying to create value for companies using artificial intelligence. And I think I saw mainly 3 parts that were very difficult for companies to do. And we kind of ended up not saying that we don't think this will create value for you because you don't have this or that. And of course, the first thing is, as like I said earlier, data. They did not have large enough quantity of data, maybe not good quality on the data, maybe not structured data. They were not able to kind of create the systems that need from this data. But I think also a second problem was that they just put some, like the statistics on the problem, like here is the data, create a machine learning system. And what is very important with machine learning is that you actually need to have domain knowledge. When you create a system, you actually need to know what the data represents, because just putting a lot of data into a neural network and there you go an answer, it doesn't very much often work that way. You have to kind of do a lot of engineering with the data and knowing what to do with the data beforehand. That's also very important to kind of combine domain knowledge about the field that you want to use machine learning on and machine learning. And a lot of people at least don't know this yet and does this in the correct way. But I also think the third problem is, of course, a bit like Birgit said, like getting the companies to use AI, getting it integrated. Like people don't have so much trust yet in that AI system can solve the problems. At least maybe if they have it, they might not even use the AI system. They won't like to use how they did it before. So it's important to kind of have an adaptation plan, how you want to make the AI system come into progress and kind of get the funding you need from the company to give some funding into creating the systems. So I think like also trust is an important challenge when implementing AI in a larger company.
Mm-hmm. Xiaopeng, what's your 5 cents here?
Yeah, so I think it's very well elaborated by Majid and Alise here already in 2 very connected questions. But one thing I want to double click on is that the fact when we go into a development process for a machine learning solution, let's say, you have to combine data science with domain expertise, right? So it's as important to have domain experts in the team as to have an excellent data scientist in the team. Because every AI problem is a business problem, right? It's a domain problem. You have to define that to start with. So I think that's really important. And that's actually one of the reasons why many AI projects fail, because they don't start by defining a clear business challenge or a business objective for that particular project. They're starting from the technical side. They're trying to showcase something really cool from a technological point of view without addressing the business concern. So I think that's one of the things I want to highlight here.
Mm-hmm. So I'm eager to get to the next question, if we can get that on the screen. Michael, how can we defend IT systems against AI-based attacks? And are we entering a kind of new AI versus AI battlefield, do you think?
I'm not sure if I'm the right person to ask that. So it depends on what type of attacks you think. So if you think about security attacks using AI, I guess you can use AI systems that are specifically trained against these type of attacks. If you think about other attacks like what we can see in the US election, where people make fake content and this using AI, then it gets more challenging, especially because this content gets more and more kind of realistic. So there are some prognosis that in 5 years we will not be able to distinguish created content from real content. So that's quite challenging to prevent against that. So yeah, it's very challenging question. So I guess we just have to develop new systems to defend against these attacks, and maybe at some point we will go back to really talk to each other face to face, because otherwise we cannot make sure that it's really us talking with each other. So it's a big challenge, I think.
So what I kind of hear you saying is that the most dangerous attacks are the ones that we can't tell are attacks.
Yeah, I think so.
Yeah. Alex.
Just because I worked in like the risk and section of KPMG, and like there was a lot of cybersecurity there, I just have a comment on this, because a lot of cybersecurity threats also kind of go along sort of like more like common. A lot of it is kind of phishing, and a lot of it is kind of really, but we are seeing kind of more activity from state actors when it comes to using these more kind of complex attack methods. So I think, definitely it's a risk, and like it should be discussed, but also like automating various forms of existing forms of cybersecurity threats. That's more along the lines of, maybe something that we increasingly will see to a greater extent.
All right, so the next question is, I guess, a question about definitions. Can rule-based systems be defined as AI? And if yes, why? Alice mentioned chatbots without NLU as an example. So, Alise, do you want to start on that?
Yes, I think this can kind of be answered by definitions. As I mentioned in the presentation, that the definition of AI is just something that mimics the behavior of an intelligent being, for example, humans. So as long as, for example, chatbots are able to seem intelligent, I think it will be artificial intelligence. But it is not machine learning unless it kind of learns. So I would say that the rule-based system definitely can be artificial intelligence. I don't believe it's going to be so much of it in the future, because I don't think it is the best way, most efficient way to create a lot of systems. So I don't think it's going to be a lot of it, but I definitely say per definition it is AI, but not machine learning.
By the way, I realize now that NLU, I don't even know what it abbreviates. So natural language
understanding.
As opposed to NLP, which is natural language processing. I also know a word. Okay, so next question. How do you suggest that we communicate AI to end users? When we use the word AI, people often have the wrong idea from what they have read in the news or seen on Terminator. I added that last part. And I would like several takes on this, actually. So Majid, I will ask you first.
Yeah, I think one thing to highlight here is that the word AI can be further split into ANI, which is like artificial narrow intelligence, and then AGI or ABI, which is artificial broad or general intelligence, and then artificial super intelligence. And coming back to the Elon Musk comment, I think we're at least hundreds of years away from that. All the development that's been on Google Scholar or the internet today has been specifically to the artificial narrow intelligence. And if we can start communicating to the customers and the end users that we are in the ANI phase, which is artificial narrow intelligence, aka it can only do one thing specifically, it doesn't generalize, it has sort of a lot of limitations, then perhaps that could be one take of taking it away. With the Terminator just in my opinion, to give everyone a peace of mind, the Terminator is in like ASI, which is artificial super intelligence. We're not even in the AGI, which is the artificial general intelligence. So it's really thousands of years away. I'll put that bet there because I won't be alive to see it anyways. But we're quite safe in our lifetimes for sure.
So before we move on to the next question, I see that Alex would like to comment, and also I know that Michael has researched a lot of AI for medical purposes, and there I guess you'll have to communicate a lot of the AI results to people who've never even programmed before. So I would like to hear your thoughts on that, but I'll let Alex just mention his comment first.
Yeah, I'll make it super short. I just thought worth mentioning Sendem Elements of AI and that course. It's a basic introduction course to artificial intelligence. It was originally made in Finland, but it's been translated to Norwegian, and that gives a really good introduction. But we need to educate the general public on artificial intelligence, and that's also kind of your job to do if you're in artificial intelligence, right? We kind of need to take responsibility for this together. Good organizers here as well.
So what do you think, Michael, when you make an AI for a hospital, should you educate the doctors in AI?
Yeah, I think that's very important. So my dream for the future would be that doctors are basically have AI in their studies as a part, and they can build their own models in the future. It's not rocket science, so they're for sure able to do that. It's more kind of just educating them. And I also think that one of the biggest problems I see in the communication of AI is that it's really overselling. It's oversold by companies, by the big companies, like, oh, look, Google made this super intelligent new language model that can talk like a human. We solved Turing tests and so on and so on. And if you look into details, you see, okay, it just had a lot of data and a lot of processing power, which is ridiculous to use for such a task. And then they kind of have a nice thing to show, which doesn't have any intelligence in that sense. So I think that's kind of, we have a lot of these big companies that are really pressing into AI some picture that is not really there, which is ridiculous. So I think it's really important that we as researchers, we take kind of distribution of science and communicating science as as an important part of our job. So we'd really love to see more scientists really going out telling about projects they're doing, work they're doing, and keeping it to kind of a realistic level. So really telling about what you're really doing. You don't have to make it look better than it already is, I think. And also, I think it's also really important to talk more about what can AI actually not do. What can these methods that we have nowadays actually not do, and where do they fail? And actually show how stupid they are on some tasks and how easily they can fail. I think that's really important. So we have to be more realistic and more kind of honest about what it can really do and what it cannot do. Especially, I think, when you talk to, if you're a new AI person and you want to kind of go into the medical field, doctors are often a bit critical towards new technologies, no offense. And you kind of want to convince them that it's good for them to work with AI. And some of them maybe saw Terminator from before, so they think they can build the Terminator doctor to help them. So you have to really tell them, okay, this is the data you have. This is what we realistically can do with your data. We cannot do more than that. That's kind of the border. Do you think this will be useful for the clinical work you want to do later? Most of the time they will say, no, why should I waste my time on this? It will not be useful. But sometimes you find applications where they really say, yeah, that's really useful because it saves me time, or because it can help me to find new patterns and so on. And these are the important problems to work on. But I think there are also a lot of AI research projects that fail, that don't really have any good results at the end, because what they wanted to do from the start was kind of really not realistic compared to what the methods can do. And then they produce some papers, or maybe a really narrowed down version of what they proposed. And no one is really gaining from that, I think. So I think the most important message is be realistic and talk more about what it can actually not do.
Yeah, I guess for a field to be kind of honest about negative results, it takes some amount of maturing, because we're still in the phase where it's awesome, and journals can kind of say that no, only breakthroughs, please. So maybe we'll arrive at the point where we can also share what didn't work. So we have 10 minutes left. So I guess we should just sprint on to the next question. What is the biggest breakthrough technology-wise in the last, or what will be, I guess, in the last, no. What was the biggest breakthrough technology-wise in the last 1 to 2 years? It seems like the hype is slowing down a bit. Who wants to start on that? Xiaopeng?
Yeah, so I can just mention one thing we haven't discussed yet. So when people think about developing AI and machine learning models, normally it requires massive amount of data and huge computing power. So you think about either running that on supercomputers or doing that on cloud services, which are offered by the leading tech players. But what has been one of the breakthroughs in the past few years are really developing and deploying AI solutions on the edge. So that's really where AI meets IoT. So I think that's very interesting because with edge computing, you are able to actually develop and train machine learning models at where it's closest to the data, to where you gather the data. So there's obviously benefits. For example, from a latency point of view, you can do real-time processing, which can reduce the latency for mission-critical assignments. And then on the other hand, you can also train the model and deploy the model without transferring the data into the cloud or into somebody else's computer in the first place. So obviously, for use cases where this is super sensitive and you have to be extra mindful about security, that's another good option. So AI on the edge is definitely something in rapid development in the past few years, but also in coming years.
Majid, yes.
Yeah, to build on Xiaopeng's answer, I don't think there has been sort of any major breakthroughs in terms of AI the past even 30 years since Lee Kon published his papers in deep neural networks. We can see a trend in many papers that the neural networks are just getting deeper and deeper and deeper, but that's because the resources are allowing that and the amount of data generated is allowing that. So in terms of the state of the art, neural networks haven't really changed for several decades now. But as Xiaopeng highlighted, the breakthroughs are coming in terms of applications. Before we needed the sort of a powerhouse to run a convolution, a CNN or a machine learning algorithm, but now you can run it on your phone. So it just seems to be, in my opinion, it's becoming more and more production oriented, although still 85% of projects fail, but it's still much better than it was 30 years ago. So that's my take on it. There's no breakthroughs.
Alex, I can imagine that you want to kind of challenge or at least nuance that a bit.
I don't think I want to challenge it because I guess it depends on like where you stand, and but I think the breakthrough from AlphaFold in kind of protein structure discovery is quite interesting because it took quite a long time and it is quite costly to discover protein structures, and if they can cut down that time, that's quite interesting. Maybe Michael has a comment on this that is more nuanced than me as well. But understanding how a protein works can allow us to kind of create hypotheses about how to affect it, control it, or modify it. So I think that's quite interesting. But maybe you want to nuance that, Michael. Possibly, I'm not sure. You have this domain competence combined with the others, so.
So unfortunately, I have to agree with the others that I don't think there was any major breakthrough. So as you say, I think that everything where you really use AI in the reality for a real project and it really works and is used on edge devices or whatever, that's kind of the breakthrough at the moment that I also agree on. Everything else, like these huge language models and whatever, I'm not sure if this is a real breakthrough. That's more a clever use of data, a lot of processing power, often questioned about, do we actually really need to waste so much resources on this? And also, yeah, people still using the CNNs from a really long time ago, or LSTM from '98 and so on. So it's no, and you see often also research papers where people kind of try to make something much better and they get 1% more compared to the method that was used 20 years ago. And I don't really see a breakthrough there. So I think in terms of really bringing the AI field forward, there is no real breakthrough. Maybe a breakthrough that is worth mentioning is that people now are a bit waking up on ethics and explainability and these kind of things, because these are important things to make it even more useful in the real world. But apart from that, on the methods, I don't really see any major breakthrough.
Alise, you had a comment. Do you want to share it briefly?
I think a very quick answer from my side is data. It's like for every year that goes by, the amount of data in the world actually doubles. So I think that the methods for AI and machine learning has been there for quite a while, but what we now we have data, a lot of data that can create better systems that we ever had. So I think that's the breakthrough from my side, at least.
That's a good answer. It's kind of out of the box. Xiaopeng, can you beat that?
I can beat that, but I do have something slightly from a different perspective I want to mention. So I think, for the past few years, we have seen more and more companies developing more sort of a democratized AI platform, so to speak. And by that, we mean, solutions like auto machine learning. So basically, enabling people who are developers or people who don't even code to develop AI and machine learning solutions. One example is the auto ML solutions on Azure and also on Google Cloud Platform. Another example is a startup in Sweden called Pautarian, and who are developing sort of a enterprise AI platform. So what they do is they have a sort of a drag and drop visual designer for machine learning solutions. So basically, you can upload your data and you can choose, okay, this is how I want to do the feature engineering, and those are the models I want to run on my data. And then you can based on the parameters that you want, actually have the system training the model and trying out different models on your behalf, and then you can choose the one that works for you for the best. So I think that's one of the trend and one of the breakthrough more from a commercial point of view that's worth mentioning here.
All right, thanks a lot. Now we have 3 small minutes left, so I think we'll treat ourselves to one last question, which is if the future of AI will be more like internet. So I guess if it will develop more into kind of the kind of body that the internet is, meaning not governed by one or many bodies, but a collection of all, and it contains all sorts of bad and good implications. Will AI democratization happen? Now, interpret this freely and answer it in 20 seconds. Who wants to go first? I'm just going to pick one. Majid, you go first.
I think as Alise mentioned in her slides, when AI sort of can be used in sort of good or bad way, and I don't see it being government by individuals, but rather there will be many bodies contributing to it as it becomes more and more open source and more data is available. I don't really see it developing into the internet, but rather there'll be all these private individual silos within borders because of standards, for example.
Thank you, and also for keeping it brief. Alise, what's your hot take?
I'm positive, so I think the world might go together and kind of democratize, do it, set laws and regulations for AI. I think, like, for example, GDPR is a step towards that. We see that the whole of Europe goes together and try to protect our data. So I'm positive that the world kind of will set rules on how AI will work in the future.
All right, Michael, what do you think?
Yeah, I'm not sure. I mean, if you look at how AI is spread out in the internet, it's already everywhere in a way. So there are good examples, like how you make a fake Tom Cruise with the latest kind of good example, and also how you use it for making medical applications and so on. I don't really think people will start using it in a good way, so we will need some control at some point, I think.
Alex, do you agree with that?
Yeah, I think we're already in the process of trying to kind of understand how we're going to do that. But it requires a lot of effort and commitment from both researchers within, like, from a technical standpoint, but also that people within policy engage with this from other perspectives, and that they come together to discuss it, because it's the internet was open, but it's still been a question of power, and it's still localized somewhere, and there's all these kind of different relationships between countries and the world that we live in as well, that cannot be ignored as well in the discussions of the internet. So so I think that still applies to artificial intelligence.
Yeah, and I guess we also have the added complication of not living in a Disney movie where actors are either good or bad. Xiaopeng, do you want to answer this question also? And then I guess the clock's out.
Yeah, so there comes the music. So yes, so I want to say that the AI will not become internet, but internet will be fundamentally changed by AI. Both in the consumer space, thinking about how much time you spend on TikTok due to their fantastic algorithm. So consumer behavior will be changed, and also on the enterprise space, how companies leverage AI, develop AI will be changed. Yeah, with that, I want to wrap up the session today. I want to thank Inga for the fantastic job, operating as the moderator and really doing a great job facilitating the discussion. I want to thank all the panelists for joining today, and specifically Alise for also giving the introduction talk. And last but not least, for everyone who have been interacting with us, engaging with us, posting all the great questions in the chat window. So thank you for joining today, and hope to see you very soon again.
Yeah, thanks everybody. See you.
Thank you. Bye-bye.
Bye.